Hey everyone, if you've ever written even one line of Java, you've definitely used something called literals, even if you didn't know what they were called. They're the fixed values, the actual raw data, like numbers and text, that are the absolute foundation of every single program. So today, we're going to break down exactly what they are and how to use them like a pro. Let's get right into it. All right, let's start with a pop quiz. Take a look at this line of code. I'm sure you've written something like this a million times. We've got an integer variable, num, and we're giving it a value. But my question is, what do we actually call that 9? It's not the variable, it's the data itself. Any ideas? If you guessed literal, you are absolutely right. A literal is just the official name for any fixed value that you type directly into your program. The number 9, the text hello, the value true, yep, those are all literals. They are the literal, actual data that we're working with. Simple as that. So, here's our game plan for this explainer. We'll start with what I call the Integer Toolkit, checking out all the different ways to write whole numbers. Then we'll jump over to floating point numbers for decimals. After that, we'll get into the logic behind characters and booleans before we tie everything together with a quick final recap. First up in our toolkit are the integers. Now, these are your basic, everyday whole numbers, but as you're about to see, Java gives us a few different and really useful ways to write them down in our code. Now, this is pretty cool. All 3 lines of code you see here do the exact same thing. They assign the value 10. We're all used to the first one, the decimal system. But Java also lets you write numbers in binary, just by starting them with 0b. This is super useful when you're working with low-level stuff like bit masking. And then there's hexadecimal, which you start with 0x. You see this all the time for things like color codes or memory addresses. It's all about choosing the right format for the job.
Okay, take a quick look at this number. Can you tell me how many zeros are there without counting one by one? It's kind of hard, right? It's so easy to get lost, and believe me, counting zeros wrong is a classic way for bugs to sneak into your code. Our brains just aren't great at parsing long strings of digits. And this is where Java has a simple but honestly brilliant feature. You can just pop underscores into your number literals to act as visual separators. The compiler? It totally ignores them. They are purely for us humans to make the code readable. So that confusing string of digits instantly becomes a clear, easy-to-read 1 billion. So much better. All right, we've got whole numbers down. But what about values that have fractions, like prices or scientific data? For that, we need to pull out our next tool, floating point literals. So a key rule in Java is that any number you write that has a decimal point is automatically considered a double type, which gives you a lot of precision. Now, for numbers that are just massive or incredibly tiny, writing them out is, well, it's a pain. That's where scientific notation comes in. The EUC here just means times 10 to the power of. So 12E10 is just a much cleaner way to write 12 with 10 zeros after it. Perfect for science and finance stuff. Okay, let's switch gears from numbers for a minute. Our next set of tools deals with 2 really fundamental ideas: how to represent single symbols and how to handle logic with simple true or false values. Now, this is a really, really important one, especially if you're coming from another programming language. In Java, Boolean literals can only be the keywords true and false. That's it. You absolutely cannot use 1 or 0. If you try, like you see on the don't side, Java will give you an error. It's one of those strict Java rules that actually helps prevent a lot of confusing bugs. Next up, we have characters. A character literal, or char, is always just a single character. And the most important thing to remember is the syntax. It's always wrapped in single quotes. Double quotes are for something else entirely, which we'll get to later. So A, Z, or even 7 can be a character literal. And here's a fascinating little twist. Behind the scenes, every single character is actually represented by a number based on the Unicode standard. And because it's secretly a number, you can do math on it. Check this out. If you take the character A and just increment it with letter plus plus, what do you get? You get B. How cool is that? It's a really neat trick to remember. Whew, we have covered a lot of ground. We've looked at integers, floats, booleans, and characters. So let's bring it all home with one final handy cheat sheet just to make sure these concepts are locked in. Okay, here it is, the key takeaways. For binary numbers, start them with 0b. For hexadecimal, it's 0x. Remember to use underscores and long numbers to make your life easier. For scientific notation, use the letter E. For booleans, it is strictly only true or false. And for single characters, always use single quotes.
This slide is basically your quick reference guide.
So now you know how to represent all these fundamental single pieces of data in Java. But that raises the next logical question, right? What happens when we want to combine characters to make words and sentences, like the classic hello world? Well, that's where string literals come in. And that is a perfect topic for our next explainer. Getting these basic literals down is the first crucial step to writing clean, readable, and really powerful Java code.